I'd like to introduce CommCP, which focuses on efficient communication among large model-based multi-agent systems. The process involves three main modules: perception, communication, and planning. Each agent performs a confidence check when answering a question to ensure the task is answered with sufficient confidence. In the communication module, agents observe the environment using VLMs and then generate potential communication outputs with LLMs. These outputs are calibrated by conformal prediction before being shared with other agents. This collaboration helps avoid unnecessary exploration paths. The planning module combines information from the VLM and natural language messages from other agents to generate a semantic value map, which serves as a heuristic for path planning. This step ensures that communication leads to meaningful and effective task execution. In this visualization, we compare different configurations. The first video shows the no communication setup, where each robot independently focuses on its targets. The second video highlights communication without conformal prediction. Although agents share information, it leads to misdirection and inefficiencies. Lastly, our method with conformal prediction guides the agent more effectively to its target. This slide shows additional experiment visualizations that contrast task completion with our method versus no answer sharing. Our method clearly demonstrates improved task completion time. Next, we present two real-world demos across different scenarios and scene sizes. The first scenario takes place in an office. At the beginning of exploration, Robot 2 sees a monitor, but isn't confident enough to answer Robot 1's question, so it initiates communication. Meanwhile, before receiving the message from Robot 2, Robot 1 spots a white plate relevant to Robot 2's target object, bread, and shares this information. As a result, each robot navigates to the location shared by the other and successfully answers its assigned question. Finally, Robot 2 continues exploring and answers its remaining question. The second scenario takes place in a multi-room environment, with the main scene set in a cafe. At the beginning, each robot explores the large environment to locate its assigned target objects. Robot 1 is the first to find a target object, a blue backpack, and successfully answers one of its questions. While continuing its search, Robot 1 clearly sees a TV, which is relevant to one of Robot 2's questions, and helps Robot 2 answer it. Shortly after, Robot 1 spots a monitor, but isn't confident enough to answer Robot 2's related question, so it communicates this to Robot 2. Subsequently, Robot 2 navigates to the location shared by Robot 1 and successfully answers the question. Meanwhile, Robot 1 answers its final question and concludes its exploration. Finally, Robot 2 moves into another room and successfully answers its remaining question. Together, these two demos highlight the effectiveness and deployability of our method in real-world environments. That's all. Thanks for your watching.